Hello. So I'm Amy. That's really echoey. Also a data scientist here, and I'm going to be talking to you today about how we use machine learning methods to keep our users safer in our app. So Clement's already talked about what Depop is a bit, so I'm not going to just repeat what she said. But as that sign says, we kind of define ourselves by being a social marketplace. I get if you haven't used the app, that's kind of hard to understand how shopping can be social, but basically all it means is that we are community driven. So, it's not just shops and money, we actually see the people behind it. So, you can share your shop on social media, follow other users, like items, comment on items. And often a buyer will message a seller being like having questions about something. What size does this actually fit up to? And so that opens up a level of trust between buyers and sellers. However, this level of trust also opens up the door for abuse to happen. So examples are just, people spamming other users, inappropriate comments sent to other people, and also a surprising amount of people messaging their exes on Depop because they've been banned on everything else, or like blocked on everything else, which is really good. So when that type of abuse and stuff happens in the app, our moderation team takes over. So we have a really good moderation team here, but the process to kind of get your report looked at is actually quite long. So the general steps that a user would take if they want to take something down is they have to find the correct report form, and sometimes people might not even want to report what happened to them at all. That's their decision. So they'll fill out a form like one of these with all the details. It then goes to our moderation team, and they have kind of a queue of tickets, so they have to look at these one at a time manually, which takes quite a long time. So we have 7 full-time staff on moderation and get literally thousands of reports in a week. That's a lot to look through. So as we've begun to grow, we've created quite a few tools using machine learning that kind of helps make moderation's job easier and keeps our users a bit safer. So I'm going to talk about one of those models specifically today, and that is our model that detects phishing. So you've probably had phishing messages before with someone being like, your Nigerian prince cousin died and you're now a millionaire. They just want to get some sensitive information out of you so they can basically scam you. The way that this happens in Depop is someone will make an account and send a really generic message to hundreds of users over the course of minutes that basically follows a pattern that's like, I saw your item, I really like your item, and I'd like to purchase it for this much money. They'll usually offer a bit more than the listing price so that the buyer kind of has incentive to be like, oh yeah, okay, cool, I'll follow that up. They'll try to sound really legitimate. We've had examples where people are like, my mom wants to buy this, but she's a policewoman and she's at work, or I want to buy this, but I'm at church right now, so I can't send the money over. To us, this is obvious that it's not a real user, but people do actually fall for this, and historically people have lost hundreds of pounds. So we obviously want to stop it. The general tactic is just give some contact information where they can get the user out of the app, and obviously out of the app, we don't have any power anymore. Whatever happens, it's kind of, we just can't really do anything. So you can see this is kind of an altered example of something that someone sent. And you can see how they've altered the message to get around kind of just straight up pattern matching filters. So they've added random spaces in where they don't need them, random capital letters where they don't need them, more unnecessary punctuation. And the phishers have also adapted in other ways. So they've learned our working hours, and once it hits 6 p.m., just go absolutely hardcore with the messages. So yeah, we built a pretty good model to detect and ban these users as quickly as we can. So I'm gonna go on a little journey where we process this message and then put it through our model. So we actually had a model in place before where we used a type of online learning. So when the phishers adapted, moderation could add those messages into the training data and then retrain it. But it suffered from a catastrophic forgetting problem, which basically meant it forgot everything it had learned before and only focused on the new things. So the model just stopped working, and people were sending hundreds of messages. So we thought, okay, the model that we need is going to have to be very simple. And there were two main reasons for that. One was moderation had been saving data, but there wasn't really all that much. We only had about 1,000 examples of actual phishing messages that had been sent. And we needed something that was efficient because we want to ban these people as soon as possible. Like, it's really good having a complex deep learning message, but if it's going to take an hour to actually get to that message, to process it and be like, oh yeah, that's phishing, like, it's completely pointless. You can send so many messages in that time. And obviously the more people you message, the higher the rate of response becomes. So, oh sorry, we just went with logistic regression. So obviously first, we have to pre-process the messages that come in. So there's some just generic text processing, like making everything lowercase, removing stop words, but then something kind of more task specific that we did was replace all digits with zeros. That was initially done to try and detect phone numbers because, like, as you know, a computer sees like two phone numbers, even if they're one digit different, like it's completely different things. So by making them all zeros, it's like, oh, that's a string of length like 12, 11, I don't know, some length. And it actually also helped with kind of the emails that the phishers would send. So obviously the phishers make like fake emails. Well, they're real emails, but it's not actually one that's actually being used. And they tend to follow a generic pattern of like first name, last name, 3 digits at gmail.com. So that actually also helped with that. Yeah, so after that's done, we create 2 versions of the message to get some features. One is just word-based, so you just split it on white space, that's all done. But we do some like character-specific processing. So the reason that we do this is because, like, from the examples that you see, phishers think that they can get around being detected by just throwing in random spaces, random punctuation. So we just get rid of all that, like just remove everything that isn't alphanumeric. And you see it just goes to this like kind of nonsensical string. And then just to train the model, we concatenated those features. So we just did a range of n-gram term frequency, inverse document frequency features. Just used a grid search to find the best parameters of the model. And as you can see, our results came back like suspiciously high. But when you think that, you know, the phishers are just the same people coming back and coming back. They use the same language. It's biased in that way that, you know, the same person uses the same type of language. So it's not actually all that shocking that the results are that high, but what is important is, you know, does it actually work when we implemented it? So we built a Scala service to implement the model and actually be able to ban users. We analyze every message sent that comes into the app. Like, we can do that because we just chose an efficient model. It works in like less than milliseconds. So yeah, we analyze every message sent and keep track of messages that came back as being detected as like phishing. And then, so we ask 2 questions about users. We look at, in a certain time period, how many phishing messages have they sent, and how old is their account? Because users typically just make an account and then just go for it, just start messaging like hundreds of users with no actual activity before that. And so we're able to do this pretty like memory efficiently with the use of a cache. So that's basically just like a dictionary, but the contents expires after a set time limit. So, you know, we can look at in the time period that we sent, what's the length of the list of messages. If it goes over our threshold, we hit the API, see how old the account is, and if it's quite young, we just ban them. So does this actually work once we put it into production? And yeah, it did, yay. So pretty quickly, reports went down by about 30 to 40%. And in the long term, we're finding that we're consistently banning about 10 users a day for phishing, which doesn't seem all that much, but when you think that a few months ago, they could come in and message like 300 people overnight, that's 3,000 3,000 messages that we've saved, and 3,000 users that we stopped from, you know, being open to harm. So yeah, the model and the way we process has continued to, the phishers are still going along that route of just like, I'll add 4 full stops. They just go crazy on it. And so our processing's actually kept up with that, so that's nice. So yeah, what else have we learned from this? So for us, a simple approach was the best approach. You know, we had task-specific pre-processing, which really helped with, once the model actually had input, how it worked. And this pre-processing allowed us to adapt to the new messages that phishers were sending. So yeah, our bad users are predictable until they learn that they're predictable. So the messages are still getting detected as phishing when they change them. But they've started to learn like, oh, if I make an account and leave it for a week and come back, I'm not gonna get banned. Like, I'll be reported, but I'm not automatically gonna get banned. So I think in future we need to find a way around that, use a bit of a smarter way than just hard-coded rules. But yeah, other than that, it's gone pretty well. So our moderations lives are a bit easier, our users are a bit safer. So yeah, that's kind of it.